And how can we derive dimensional formulas without by heart? The first dimensional formula is
area.
okay. So let us see here now. First is area. Area is nothing but length into breadth. Okay. So length into breadth means length is also length, breadth is also length only. So we write L square. So in this m is not there. So m power 0 and t power 0. What is the next dimensional formula? Volume. See, volume means length into breadth into height. All the three are lengths only. So m is not there here. M power 0, L cube, t power 0. This is the dimensional formula for volume. Next, density. So what is the dimensional formula for density? Density is nothing but mass by volume. Mass means m. Volume means L cube. Just now I told you. Okay. So what is the dimensional formula for density? M L power minus 3 t power 0 because t is not there here. Okay. So velocity. Put check the dimensional formula. Verify check. Is it true or correct or not? Just see that one. Okay. Next entity. Velocity. So velocity means displacement by time. Displacement means length and time is t. So here velocity means mass is not present. So m power 0 L t comes to numerator become t power minus 1 is going to be the dimensional formula for velocity. What is the next?
Acceleration.
Acceleration. So acceleration is nothing but acceleration means change in velocity by time. Okay. So change in velocity. Velocity means displacement by time whole divided by t. So therefore acceleration A is s and this t becomes t square. So therefore this is going to be L by t square. Here mass is not present, so m power 0 L t power minus 2 is going to be the dimensional formula for acceleration. What is the next one?
Force.
Force. So force you want. So force is nothing but mass into acceleration. Mass is m. Just now I told you acceleration is L t power minus 2. Is it okay? L t power minus 2 because acceleration means change in velocity by time. Velocity is nothing but displacement by time whole divided by t. So A is nothing but s by t square, which is L by t square, which is nothing but L t power minus 2. So I have written directly here. Is it? Next, work. So what is the dimensional formula for work? Is nothing but force into displacement. Okay. So what is the work done? Work done is force into displacement. Mass into acceleration into displacement. Mass is m. L t power minus 2 is the acceleration and L here. So therefore the dimensional formula for work is ml square t power minus 2. Next, energy. See, energy means you can take a kinetic energy here. Half does not have dimensions. M is m only, and the dimensional formula is displacement by time for velocity, which can be taken as L by t, which is nothing but L t power minus 1. So therefore L t power minus 1 whole square gives you m L square t power minus 2. It is understood that the dimensional formula for work and energy is going to be same. Then what is the dimensional formula next? Power. So power is nothing but work by time. Work is nothing but force into displacement by time. Okay. So force into displacement by time, which is force. Displacement by time is nothing but velocity. So force is nothing but mass into acceleration into velocity. F is equal to ma. So force, mass, acceleration is how much? L t power minus 2. Okay. So velocity is nothing but L t power minus 1. Therefore power is nothing but m L square. Okay. So what is that? T power minus 3. Or you can just write power is equal to work by time. If you could remember the formula for work, which is nothing but ml square t power minus 2, just divided by t. This t comes to numerator becomes t power minus 1. This becomes t power minus 3. This is also one more method. If you can remember the dimensional formula for work. That's it. Next. Momentum. So here momentum P is nothing but a product of mass into velocity. Mass, velocity is nothing but L t power minus 1. Next.
Gravitational constant.
Gravitational constant means G. Okay. To find out the G, we should know the formula for universal gravitational constant, which is F is equal to G m1 m2 by r square. G is nothing but F into r square by m1 m2. m1 m2 can written as m square. Both are mass. So what is the dimensional formula for force? Force means mass into acceleration, which is ml t power minus 2. Radius is nothing but length, so we can write L square. Mass is nothing but m square. So m square, m gets cancelled. So G is mass goes to numerator become m power minus 1. L square is going to be L cube, and this is going to be L t power minus 3. Next.
Plane angle. Plane angle.
Plane angle. So plane angle means I think no dimension for that.
Angular velocity.
Plane angle. Angle, for angles there is no dimensions. It's a number, 30 degrees, 40 degrees. So what is the next one?
Angular velocity.
Angular velocity. See, angular velocity is nothing but angular displacement by time. For angle there is no dimension. So the dimension for this is just t power minus 1, that's it. नहीं वो लाइन से जा रहे हैं लास्ट तक आया था तुम्हारा भी आया था उसमें
Angular acceleration.
angular acceleration. So angular acceleration is nothing but angular velocity by time. Angular velocity is nothing but angular displacement by time. So alpha is nothing but theta by t square. For theta there is no dimension, for angle there is no dimension, so dimension is nothing but t power minus 2.
Angular momentum.
Angular momentum is given by MVR. It is there in chemistry. Angular momentum is quantized. MVR. So the dimensions for M is M only. V is nothing but L to the power minus 1. R is nothing but L. So M L square T power minus 1 is going to the dimensional formula for angular momentum. Next. Moment of inertia dimensional formula is mr square. So I is equal to m. This is L square. T is not there. So you can write this as e power 0. Next. Torque. See, torque is nothing but force into perpendicular distance. So force is nothing but mass into acceleration. Distance is L here. So m L T power minus 2 L. So therefore torque dimension is ml square T power minus 2. This is similar to work or similar to energy. Next.
T power minus 1.
Hmm?
T power minus 1.
For torque.
Yes.
Force into perpendicular distance. Force and mass into acceleration into length. So acceleration means L to the power minus 2. L square L to the power minus 2. Correct only. Leave it. Next.
Angular frequency.
Angular frequency. So angular frequency and omega na? Huh? So angular frequency is nothing but theta by t, which is t power minus 1 ante kada. Chudu.
Frequency.
Frequency. Frequency. See, frequency is nothing but reciprocal of time period, so t power minus 1. Next.
Period.
Time period. Time period is nothing but t only.
Young's modulus.
Young's modulus. See, this is very important. See, okay, here let me discuss the formula for modulus of elasticity. This, if I explain now, elasticity whole chapter, properties of solids, elasticity, all will finish. That whole chapter I will revise by explaining the dimensional formulas. So here, first of all, to understand the modulus of elasticity, you should know first of all what is the general formula for stress. See, stress or pressure, both are going to be same. Stress or pressure is nothing but force by area. So stress and pressure and force by area. Force means mass into acceleration by area. Mass means m L to the power minus 2. Area is nothing but L square. So getting cancelled. So stress or pressure formula is going to be ml power minus 1 T power minus 2. So this is called as stress. This is a general formula for stress. Now let me discuss what is the formula for strain. Strain means what, you know? Strain means change in dimension by actual dimension. Change in dimension by actual dimensions means if it is a longitudinal strain, it is change in length by actual length. Okay. If it is what is said to be bulk strain, if it is bulk strain, change in volume by actual volume. Next, if it is a rigidity strain or tangential strain, any strain you take, change in dimension by actual dimension. All are going to be ratios. For a strain, there is no dimensional formula because it is going to be a ratio. So we can write this as m power 0, L power 0, T power. There is no dimensional formula for strain, whatever the be the strain here. Next, see what is the dimensional formula for modulus of elasticity? Modulus of elasticity, either it is length modulus or rigidity modulus or bulk modulus, for all same formula. Why? Because modulus of elasticity is nothing but stress by strain. It can be longitudinal stress or what is said to be bulk stress, or it can also be called as tangential stress. As strain does not have dimensions, only stress is left. And you know stress, see modulus or stress, both are going to be same dimensions, because strain is removed from the scene, so only stress is left. Stress or pressure, which is nothing but force by area, m, and force means mass into acceleration, Lt power minus 2 by L square, so getting cancelled here. So stress means pressure, which is nothing but ml power minus 1 T power minus 2. For modulus of elasticity or stress, both the formulas are same. Even pressure also same formula. Next,
Shear modulus.
same formula.
Pressure.
Same formula.
Surface tension.
Surface tension. See, surface tension, which is taken as F here. Surface tension is nothing but tension per unit length. See, tension or force, both are going to be same here. Force per unit length. Okay, tension is nothing but force per unit length. The formula for tension is nothing but force per unit length here. Force means mass into acceleration by length, which is nothing but mlt power. Acceleration is Lt power minus 2 by L. LL gets cancelled, so surface tension formula is ml power 0 T power minus 2. Next,
Coefficient of viscosity.
coefficient of viscosity, very important. Many times it is repeated. Many times it is repeated. So what is coefficient of viscosity? For that you should understand. You should understand one concept which is present in the fluids. See, you know that all the canals are constructed in which shape? V shape, like this. KC canal, you see, this type of shapes are present, and water flows in the form of layers. Why this type of shape is given to the canals, not this type of shape is not given to the canals, U shape, only V shape is kept? The reason for that is here one layer is sliding over the another layer. See, water flows in the form of layers. Upper layer moves forward, means lower layer, this layer is trying to stop the upper layer. If upper layer tries to move forward, this lower layer tries to move, stop it, tries to apply some force backward. That is what as viscous forces. And upper layer, what it does, it tries to take the lower layer along with that. That is called as viscous drag. Viscous drag. Viscous forces or viscous drag, it depends upon something here. What is it? Viscous forces are directly proportional to area of the below layer. If the below layer is smaller than the upper layer, viscous forces will be lesser. Understand? And viscous forces is directly proportional to velocity with respect to depth or not. Velocity with respect to depth means what? Viscous forces decreases, or viscous forces are directly proportional to velocity with respect to depth. Means what? Velocity decreases as you go down. Upper layer moves with the speed of 2 meters per second, means lower will move with the speed of 2 meters per second. Still lower layer will move with lesser speed, 0.5 meters per second. Still lower layer will move with the speed of 0.1 meter per second. As you go deep, velocity decreases. So decrease in velocity with respect to depth is called as the next thing here. So if you join these two, viscous forces are directly proportional to A, and this is delta V by D. Okay, so viscous forces like this, area, velocity by depth. If you remove this proportionality, you will get neta A, change in velocity with respect to depth. So this is going to be your formula. Okay, so what is your formula for viscous forces? This is going to be the formula. Therefore, coefficient of viscosity is nothing but F and D by V into A. And then F D AV. Force means mass into acceleration, mlt power minus 2. Distance means L, and velocity means Lt power minus 1, and area is nothing but L square. So L square gets cancelled. So coefficient of viscosity is M. L comes to numerator, become L power minus 1. T power minus 1 comes to numerator, T power plus 1. T power minus 2 plus 1 is T power minus 1 is going to be the dimensional formula for coefficient of viscosity. Next,
Wavelength.
wavelength. See, wavelength means it's nothing but length, that's it.
Intensity of wavelength.
Hmm?
Intensity of wavelength.
Okay, see, intensity dimensional formula is very important. Intensity or solar constant, both are having same dimensions. He will ask sometimes solar constant also. Solar constant is given by letter S. So what is the meaning of intensity? Intensity ante I. Intensity means power by area. The formula for intensity is power by area. Okay. So power. You all know power is nothing but work by time by area. Work by power is nothing but work by time or energy by time. So just you can find out the dimensional formula for intensity. Work is nothing but m L square T power minus 2. This is time T. This is L square. Area means L square. So L square gets cancelled. Intensity means ml power 0 T power minus 3 because T comes numerator becomes T power minus 1, which is T power minus 2 minus 1, which is minus 3. That's going to choose for check books. Okay, never get mistake. Okay. Heat low, okay, heat energy.
Only heat.
Okay, so here heat energy or quantity of heat energy. So what is the dimensional formula for quantity of heat energy? See, quantity of heat energy or energy, any energy you take, same formula. Doesn't worry about that whether it is a heat energy or light energy, anything you can consider. Electrical energy. So whatever it may be, the dimensional formula is same, ml square T power minus 2. Then what is the next formula?
Specific heat capacity.
Specific heat, very good. See, quantity of heat is directly proportional to mass. If you take smaller mass, you require smaller heat to light it. Okay, small chip of wood you want to burn, you take a small mass stick. Big log you want to burn, you require a lot of heat to supply. So quantity of heat is more when mass of the body is more, and quantity of heat is increasing when temperature increases, heat is also increasing. You join these two, Q is directly proportional to M delta T. If you remove the proportionality, it becomes MS delta T. Where S is said to be specific heat, is asking specific heat only. So you have to find out the dimensional formula for S here, okay? So how are you going to find out the dimensional formula for S? S is equal to Q by M delta T. So quantity of heat energy or energy is ml square T power minus 2, mass is M. Delta T means temperature. Temperature can be given by letter K or theta. Temperature means K తీసుకోవచ్చు Kelvin, లేదా temperature can also be represented letter called as theta. Theta or K, both can be used. So I have used K here, mm gets cancelled. M is not there, so m power 0, L square T power minus 2, K power minus 1. See, verify the formula. Verify the formula. Okay. So what is the meaning of latent heat? See, quantity of heat energy is equal to m into latent heat. M into latent heat. This formula is used while melting of ice or boiling of water. See, during the melting of ice, temperature remains constant. While boiling of water also temperature becomes 100 degrees Celsius. While melting of ice also temperature is going to become what? Constant. So when temperature is constant, we can't use this formula because change in temperature is 0. This will become 0. So that is not valid for latent heat. So quantity of heat energy is nothing but m into latent heat. Latent heat is nothing but Q by m. So quantity of heat energy formula is ml square T power minus 2 by m. So your formula is ready. So what is that? M is not there. So m power 0, L square T power minus 2 is going to be your formula for latent heat. That's it. Is it okay? Next.
Gas constant.
Gas constant. See, gas constant is nothing but PV is equal to nRT, where R is said to be the gas constant. So R can be taken as PV by NT. See, pressure formula. See, just I told you pressure is nothing but force by area. Force is nothing but mass into acceleration by area. ml power minus 2 by L square getting cancelled. ml power minus 1 T power minus 2 is the dimensional formula for pressure. Okay, and else volume is nothing but L cube, and N is given by the letter MOL. Number of moles is given with the letter. It's a combination of 3 letters, that is MOL. Then after that temperature is given with K. So so what are you going to get from this? Let us see. Therefore, for gas constant, we write m L square T power minus 2 K power minus 1 MOL power minus 1. This is going to be the dimensional formula for R. Is it okay?
Yes.
Next.
Boltzmann constant.
Boltzmann constant means we write PV is equal to NKT. N, this is called as Avogadro number. For numbers there is no dimension, so remove that one. K is equal to PV by T. So pressure means just now I derived ml power minus 1 T power minus 1. Volume is L cube, temperature is given K. So this K is Boltzmann constant. That K is called as a letter which is represented with letter for temperature. So this is K. So M L power minus means this is going to be L square. Volume means, okay. So how much you will get? L square. Pressure means T power minus 2, no? Pressure means ml power minus 1 T power minus 2. L cube, 3 minus 1 is 2, so ml square T power minus 2, K comes to numerator, K power minus. Is it okay? Next.
Stefan's constant.
Stefan's constant. See, Stefan said that intensity is directly proportional to fourth power of absolute temperature. Fourth power of absolute temperature. Intensity is nothing but sigma T power 4, where sigma is called as Stefan's constant, which can be written as I by what is that? I, intensity by T power 4. Intensity means I told you power passing per unit area. Power can be taken as work by time by area. Intensity means power, work means ml square T power minus 2 by T by L square, getting cancelled here. So therefore intensity dimensional formula is m. T comes to numerator, become T power minus 3. That's it. That is the dimensional formula for intensity. This comes to numerator, becomes T power minus 4. Is it okay? So is it okay dimensional formula for intensity? So therefore sigma is going to be m T power minus 7.
Minus 3, sir. Minus 3.
M T power minus 3. So what is the dimensional formula for intensity? See, absolute temperature, no? See, intensity dimensional formula, what is that? What is the dimensional formula for intensity?
MT power minus 3. MT power minus 3.
MT power minus 3 only, no? So intensity means MT power minus 3. Here, sigma is equal to I by T power 4. T power 4 is said to be absolute temperature. That is also K only, no? So in temperature. So this is also temperature. That is also temperature. T power 7.
K, sir.
Huh?
K, sir.
Sorry.
MT power minus 3. K power minus 4. Now K is power.
Sorry, sir. Okay. So what is that we have to do? Sigma is equal to I by K power 4. T and K power 4. So intensity means what? M T power minus 3 K power. So small confusion is there.
Wien's constant.
Wien's constant. Okay. From the sun light comes in the form of waves. In that maximum wavelength you consider, this is said to be maximum wavelength. See, maximum wavelength is inversely proportional to absolute temperature. Those waves whose wavelength is maximum, they are having lesser temperatures. మనిషి పెద్దగా ఎదిగినాడు అనుకో, ముసలోడైనాడు అనుకో, వాటిలో కొంచెం నిబ్బరం ఎక్కువ ఉంటుంది. క్యాబ్ సబర్ శాంతంగా ఉంటుంది, కొంచెం సన్యాసులకు ఏముంటుంది. So the more is the maximum wavelength, the lesser is the temperature. Inverse relation. So therefore maximum wavelength, remove the proportional, you will get B by T. B is said to be Wien's constant. So B means what? B means lambda m into T. See, lambda means length and T means K, because K is nothing but the temperature. LK. Okay. Next.
Thermal conductivity.
Thermal conductivity. See, you take a rod. Okay. You take a rod. You heat the rod from below. Here temperature is theta 1. Here temperature is theta 2. See, temperature is maximum where you are heating. For example, here it is 100 degrees Celsius. Here it will be 80 degrees Celsius. Here more heat, and heat is transferred from higher temperatures to the lower temperatures. And what is this? This is going to be area of cross section. This is going to be area of cross section. So thermal conductivity means what? Quantity of heat energy with respect to time is directly proportional to area of cross section. It is also directly proportional to temperature difference and inversely proportional to length of the conductor. Try to understand. The larger is the area, the speed is going to be the heat conduction. And temperature difference is high, rate of flow is also high. అంటే ఇక్కడ 100 అక్కడ 0 ఉందనుకో, ట్రాన్స్ఫర్ will be fast. This is called as thermal conductivity, means conduction of heat takes place here. So remove this proportionality, you will get thermal conductivity KT. KT అంటే thermal conductivity. A. So theta అంటే K, length అంటే L, area means you can write it as L square. Okay. Now here quantity of heat energy. Okay. See, quantity of heat energy means ml square t power minus 2. This is nothing but time. Rate of flow of heat and quantity of heat energy with respect to time. So area, see, proportionality removed, thermal conductivity constant game. Area means L square. Temperature difference or temperature both are same K. So this is going to be getting cancelled. This L and this L square gets cancelled. So KT is nothing but M. Only one L is left. T comes to numerator, T power minus 3, and this is K. So K comes to this side, becomes K power minus 1. This is the dimensional formula for thermal conductivity. Is it okay? Next.
Electric charge.
Electric charge. Charge is nothing but current into time, because current is nothing but charge by time. So current I is represented with letter A, and this is time, which is T. A means ampere. Electrical field intensity E. Electrical intensity and electric field intensity. Electric field intensity. Electric field intensity is nothing but force acting on unit charge. Force acting on unit charge. ml t power minus 2 force into acceleration. Charge means A into T. A means current. Current means ampere. So electric field intensity is ml t power minus 3 A power minus 1. Sorry, I misunderstood that one. Next.
Electric potential.
Electric potential. Electric potential is nothing but work done on unit charge. Force into displacement by Q. Q ante A into T, I into T. I means ampere into time, not area, ampere into time. So force means ml square T power minus, work done direct formula raskochu kada. ml square T power minus 2, T power minus 2, A into T. So therefore electric potential is ml square T power minus 3, A power minus 1. That's it.
Permittivity of free space.
Correct, permittivity of free space. So F is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square is going to the formula. For 4 pi there is no dimension. Epsilon comes to numerator. Q1 Q2 ante A square T square. Q means IT. I means A into T. Double times A into T means A square T square. Okay. So epsilon naught goes numerator. Force comes down. So force into R square. So A square T square. Force means ml square T power minus 2 L square. Sorry, ml T power minus 2, only one L. Mass into acceleration is ml T power minus 2 L square. So epsilon naught is nothing but m power minus 1 L cube comes to numerator, become L power minus 3. So T square T power 4 A square. Is it okay? Next.
Electric dipole moment.
Electric dipole moment means P. Charge and distance between the two charges, one positive, one negative charge. Okay, charge, positive charge plus Q, negative charge is minus Q, and the distance between them is 2L. So it's a product of charge and double times of the length. For 2 there is no dimension, so Q means A into T, and this is L. So P is equal to LTA. ఇంకా
Capacity.
capacitance. See, all of you. See, Q is directly proportional to potential. See, okay, capacitor తీసుకున్నాం. There is one battery connected, positive and negative. This is a capacitance. Capacitance of a capacitor which is having positive charge and negative charge. Charge is Q. See, potential. Charge is directly proportional to potential. The greater is the potential, the larger is the charge in the capacitor. Q is equal to CV. C Q CV. Q is equal to CV. Proportionally, if you remove, you get C. So C is equal to Q by V, and V is nothing but what is the formula for V? V is nothing but work done on unit charge. So C is equal to Q, and this is W by Q. So therefore Q square by W is the formula, final formula. Is it okay? So this is going to be the final formula here. So therefore the dimensional formula for C is Q means A square T square, because Q is equal to IT, and W is nothing but ML square T power minus 2, because it's going to be the work done here. So therefore the final formula is how much? See, C is nothing but M power minus 1, L power minus 2, T power 4, the by and A square. Is it okay? Next.
Current density.
Current density. Current density means current passing per unit area, which is current means given with ampere, area means L square. So therefore J is equal to AL power minus 2 is going to be the formula. Okay. Next.
Resistance.
Resistance. See, resistance is nothing but I. V by I. V is nothing but work done on unit charge. So work done means this is work done. Work done means M L square T power minus 2. Q means AT. Q means AT. T. A comes numerator A power minus 1. T comes numerator becomes T power minus 3. So therefore R is equal to V ante ML square T power minus 3 A power minus 1. Again one more A, because current is also A only. So ML square T power minus 3 A power minus 2 is the dimensional formula for resistance. Next.
Resistivity.
Resistivity. See, resistivity is nothing but R is nothing but rho L by A. So rho is equal to R A by L. So rho R మళ్ళీ ఎందుకు డిరైవ్ చేసుకుంటూ కూర్చుంటాం? R already you know, ML square T power minus 3 ML square T power minus 3 A power minus T power minus 3 kada, A power minus 1, area is L square, again one more L. Is it? So getting cancelled now. You ready to cancel? So what is left now finally? So finally rho is equal to M L cube T power minus 3 A power minus 2 is going to be the formula. Is it okay? Next.
Electrical conductivity.
Electrical conductivity. See, electrical conductivity sigma. So resistivity formula is there. So resistivity, okay, ikkada chesta. Let me do here only. See, resistivity is nothing but reciprocal of conductivity. Just sigma is equal to M power plus 1 become M power minus 1, L cube become L power minus 3, T power minus 3 becomes T power plus 3, A power plus 2. Now what is this? Electric flux. See, electric flux is nothing but 5 B dot A. Electric flux kada? E dot A. Magnetic flux is B dot A. E dot A. E is nothing but force acting on unit charge. A is nothing but L square. So this is M L T power minus 2 L square divided by charge and A into T. Okay, charge is nothing but A into T. Therefore, electrical flux is nothing but M L cube T power minus 3. This comes to numerator become A power minus 1. A power minus is okay. Next. Magnetic field అంటే B. Magnetic field దేని నుంచి తీసుకోవాలి తెలుసా? ఈజీ మెథడ్ B. B కి ఈజీ మెథడ్ వచ్చేసి F is equal to BIL is the formula, which is present in moving charges and magnetism. Force అంటే BIL, bill గుర్తుపెట్టుకో సార్, bill. So B is nothing but F by IL. It's very simple to This is the only formula which will make you easier to derive the formula for B. B కట్టుకోవడం ఇదే easiest. మిగతా అన్ని కష్టం formulas. So simple. Whenever you ask B, you should remember F is equal to BIL. So force means ML T power minus 2 I. B I means A, L means L only getting cancelled. So B is nothing but M. L is not there. T power minus 2, A power minus 1. Is it okay? Magnetic flux. Okay. ఇక్కడ నుంచి చూస్తున్నాం. See magnetic flux. B dot A. B means ML, M, T power minus 2, A power minus 1. A means area, L square. So, magnetic flux is, okay? And the electric flux, M, L square, T power minus 2, A power minus 1. Is it okay? Correct? Next.
Permeability of free space.
Permeability of free space. And any, see, దానికి బెస్ట్ ఫార్ములా ఏం తెలుసా B is equal to mu naught I by 2R. It's the easiest formula to find out mu naught. Mu naught కి ఇంతకంటే ఈజీ ఫార్ములా ఏది లేదు. Because you want to find out mu naught, 2 does not have dimensions. B into R by I. B అంటే ఎప్పుడు తెలుసుకున్నాం. B అంటే F by IL is the easiest formula. ML T power minus 2, I is nothing but A. This is L. L gets answer here. MT power minus 1, A power MT power minus 2, A power minus 1. So therefore mu naught is equal to M T power minus 2, A power minus 1. R is L. Again one more A. Current means A only. So mu naught is equal to M L T power minus 2, A power minus 2. This A comes to numerator become A power. Is it okay? Next.
Magnetic dipole moment.
Magnetic dipole moment. So magnetic dipole moment M is equal to I into A. I means current, A means length, area, L square. This is the dimensional formula.
Inductance.
Inductance. See, inductance means L. So to derive the dimensional formula for inductance, the easiest method is energy is equal to half Li square. Is the easiest formula we can derive inductance. Energy of an inductor is half Li square. Half does not have any dimensions. E by I square. E means energy. ML square T power minus 2. I means A, current. So the dimensional formula is going to become M. L square T power minus 2, A power minus 2 is going to be your dimensional formula. Next. Okay.